All right, are you ready? Our next topic is neutralization. So remember acids and bases. Okay, acids, low pH, 0. That's the lowest. Bases, higher pH. Highest is 14. 7 is neutral. When we're looking at concentration, no matter where we are in pH, we have H pluses and we have OH negatives. Because remember, pH plus POH equals 14. So that means at a higher pH, we have more OHs and less H pluses. And at a low pH, we have more H pluses and less OH negatives. At 7, H plus and OH negative are equal. Remember, strong acids, strong bases at the top of the table, weak acids, weak bases at the bottom. If it's a strong acid, it's a strong conductor, it's a strong electrolyte. If it's a weak base, it's a weak electrolyte, a weak conductor. We talked about Arrhenius acids. Remember, the Arrhenius acid definition is that it produces H plus or H3O plus as the only positive ion in solution, whereas an Arrhenius base produces OH negatives as the only negative ion in solution. When we're looking for Bronsted-Lowry acids, we're looking for the H plus or the proton donator. Here, take it, take it. No, really, you take it. Donating H pluses, donating protons. Bronsted-Lowry bases are acceptors of the H plus or acceptors. Yes, thank you. Thank you. I will take that. So what is neutralization? Well, it's in reality a type of double displacement reaction. It occurs between acids and bases. The reactants are always an acid and a base in water, so you'll see them as aqueous. And the products are always water as a liquid and a salt, aqueous. Every single neutralization reaction is the same. Acid plus base yields water and salt. It could be base plus acid yields salt plus water. Okay, so the order is irrelevant, but the side is not irrelevant. So the acid and base will always be on the reactant side, and the water and salt will always be on the product side. You take an acid and a base, mix them, and you get salt and water. But salt doesn't always mean sodium chloride, although it can. This is another salt. Remember, a salt is anything that is ionic, has ionic bonding. So this is acid plus base yields salt and water. 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 There you go. Let's try some examples. All right, so here we have an acid and a base. And so what am I going to get? Well, I know one thing I'm going to get for sure is water, H2O. Now I need the formula for the salt. So how am I going to figure out the formula for the salt? I'm going to take the H's off the acid. I'm going to take the OH's off the base, and then I'm going to combine the two together. Well, I'm going to need the charge of this. So this was Ca plus 2. This from table E, I can look that up, is minus 3. So when I write this, it's going to be Ca3 and then parentheses, this terrible writing, EO4. Okay. Acid plus base yields water and salt. Acid plus base yields water and salt. Acid plus base yields water and salt. All right, let's try another one. Okay, so acid plus base yields water. Oh, water. So I know water. And salt. So here's the acid, get rid of the H's. Here's the base, get rid of the OH's. Now I need to write a formula. So this, if I look it up, has a charge of -1. This has a charge of +2. So I'm going to end up with BA, and then in parentheses, NO3, and parentheses 2. Reminder, buffers. So buffers are things that resist changes in pH. So when an acid or base is added, the pH doesn't change as much when there's a buffer. So here, look, if I have pure water and I add an acid, that's H3O pluses. You see that, how dramatically the pH dropped? And then I add OH negative, that's a base, and then dramatically the pH increases. Now watch, here's a buffer, which means it's resistant to pH changes. And I add the same amount of acid, and look what happens to the pH. Very little change. And I add a base, look what happens to the pH. Very little change. So blood is an example of a buffer. It's kind of important for us to stay alive. So you can see if we had a dramatic increase or decrease in pH, we'd be dead. So in order to maintain this narrow range, blood is a buffer. So blood has conjugate acids and conjugate bases in solution, and they're just hanging out. Those bases are waiting to accept, okay? And the acids are waiting to give away, and it helps to keep us alive. So blood is one of the most important buffers. And that is neutralization.